Welcome to another video. So just imagine as a teacher, you give a function or you give some exercise to your students and ask them to find the derivative of the function. And you see a student write dy dx and looks at dy dx and goes, you know what? I'm just going to cancel the d's. And then I'm going to say that dy dx is y over x. As a teacher, you would laugh at that and go, this student must be dumb. But there are times where the student is right. Not that the student is right by just directly canceling out the d and the d under, but the answer is just going to be the ratio of y to x. Let's get into the video. I'm sure for those of you who have a full understanding of this, you would already know what the answer to this is. But let's just show it by solving a differential equation. You shouldn't do this, by the way. Don't try this at home. Okay, do not cancel the d's, but what we're saying is it is possible for dy dx to be the ratio of y to x. So let's try to solve this differential equation. So let's put a question mark actually. So we have dy dx equals y over x. If we turn this into, if we bring this y here and bring this x here, okay, so I'm going to multiply both sides by y dx. Okay, so if I multiply this by y dx, and I multiply this also by y dx, see what happens. No, dx over y, actually, dx over y. And here it's going to be dx over y. Why was I saying y dx? Okay, let's do dx over y. So the reason for this is because I'm trying to separate. Okay, so this is a separable differential equation. So now that I've isolated, you see this cancels this, I'm going to end up with dy over y. Here I have dx over x. So you see, so I can integrate both of them now that they're integrated, or I can say, okay, this is the integral of, let's write it as 1 over y dy equals the integral of 1 over x dx. Nice. Now, if I integrate both sides, I'm going to end up with natural log of y here, natural log of x, but this one is going to have plus c. Now, why wouldn't I put plus c here? Because it doesn't matter. If you give it plus c, the two c's can come together and form another c, so we don't bother putting a plus c on the left. So we're going to say that the integral of this is the natural log of the absolute value of y. Okay? And we're going to say equals the natural log of the absolute value of x. Now we do plus c. That's it. Okay, now remember we're trying to find the function that's causing all this problem. This problem of can you divide the d's? Okay, now look at this. Let's say we want to convert this back to y, get rid of the natural log. Well, we have to raise both sides to e. So if I do e to the ln, I can do e to the this. So naturally we have absolute value of y from the laws of logarithms. Here we're going to have e to the ln of absolute value of x times e to the c. But e to the c itself is another c. Okay, so let's call this c1. Okay, let's call this c1. So this is a constant, right? So we can easily say that this e to the c1, we can call it, let's just say it is c2. And we know that e to the ln of absolute value of x is just c2 absolute value of x is absolute value of y. Okay, should we leave our answer this way? No, because look at this. This absolute value just talks about plus or minus, okay? So the plus or minus here, the plus or minus here is just going to affect this c. It's going to decide whether this is a plus or a minus. That's the only thing. So Deciding whether a constant is plus or minus is just a question of another constant. So we're just going to say that if we remove the absolute values, we're going to end up with y equals c times x. This is it. Every function that looks like this would make that student get the answer if it was multiple choice. Okay, so we got check. So check. Let's do check. Okay. We have dy dx. For this is going to be c. Right? Just differentiate. You get the constant, which is the same thing as y over x, because y is cx over x, which is also c. So you see that if the student says dy dx cancel the y's, the d's, you'll end up with this, which gives you the same answer as taking the derivative. Whew. This was just a fun one, okay? Never stop learning. Those who stop learning, stop living. Bye-bye.